Good to have you back. This outcome is all about backing store, the devices that keep your programs and files safe long after the power's gone off, and how to choose between them. So let's define backing store, sometimes called secondary storage. It's where your programs and data live permanently, staying put even when the machine is switched off, which makes it non-volatile, unlike the RAM we met earlier that forgets everything at power off. It's larger and much cheaper per gigabyte than RAM, though it's slower to reach. Hard drives, SSDs, USB sticks, optical discs, memory cards, and cloud storage are all examples. And the key idea is simple: main memory is temporary, backing store is permanent. It helps to picture storage as a pyramid or hierarchy. Right at the top are the registers and cache tucked inside the CPU, blisteringly fast but tiny. Below them sits RAM, the working memory, and below that comes the backing store we're focusing on. As you travel down the pyramid, the capacity grows and the cost per gigabyte falls, but the speed drops away, so it's always a trade-off between how fast, how big, and how cheap. Let's meet the two workhorses first. A hard disk drive, or HDD, stores data magnetically on spinning metal platters, with a moving head reading it, so it's large and cheap but mechanical. A solid-state drive, or SSD, keeps everything in flash memory chips with no moving parts at all, which makes it much faster and far more robust. It's the difference between a record player and a memory chip, and it's why modern machines feel so snappy. Now, three more portable options. A USB flash drive is a small stick of flash memory, perfect for carrying files from one computer to another. An optical disc, a CD, DVD, or Blu-ray, stores data as tiny pits and lands read by a laser, and it's cheap for handing out films or software. And a memory card, like the SD card in a camera, is flash memory again, used in phones, cameras, and boards like the Raspberry Pi. These days, a lot of storage isn't even in the room with you. Cloud storage keeps your files on remote servers in a data center, reached over the internet. Think Google Drive, OneDrive, or Dropbox. It lets you get at your files from any device, share them easily, and keep an off-site backup, though it does lean on a decent internet connection and raises fair questions about privacy. Closer to home, network-attached storage, or NAS, is simply a shared drive sitting on your home or office network. Let's look inside a hard disk drive because it's a real feat of engineering. One or more platters spin at high speed, often 5,400 or 7,200 revolutions a minute, while a read-write head floats a hair's breadth above the surface, magnetizing tiny patches to store your ones and zeros. The head slides in and out to reach different tracks, and it's all that mechanical movement that makes a hard drive slower. It also means those moving parts don't take kindly to knocks and wear. Now the SSD and the optical disc, which work in completely different ways. An SSD stores data as trapped electrical charge in NAND flash cells with nothing moving, so access is very nearly instant, and that makes it fast, quiet, energy efficient, and shock resistant. An optical disc, on the other hand, has a laser reading microscopic pits and lands along a spiral track, where the pattern encodes the data. Discs are cheap to produce, which is why they've long been used for films, software, and backups. This table sets four devices against each other across capacity, speed, cost, and portability. You can see the HDD offering enormous space very cheaply, but staying bulky. The SSD delivering blistering speed at a higher price, the USB stick trading capacity for pocketability, and the DVD coming in slow and small but dirt cheap. There's no outright winner here. Each one wins on a different measure, and that's exactly the point. Let's read a bit more into those numbers. Hard drives give you the most capacity for your money, which makes them ideal for bulk storage and backups. SSDs are far quicker, which is why they hold the operating system in a modern PC, so it boots and loads in seconds. USB drives trade away capacity to be wonderfully portable, and optical discs are slow and small but brilliantly cheap when you need to distribute in quantity. It all comes back to matching the device to the job. Let's put the hard drive and the SSD head-to-head, since it's the choice most people face. The HDD wins on cost, giving you the lowest price per gigabyte and huge capacities, which is perfect for archives, backups, and bulk files. The SSD wins on experience, starting up and loading programs far faster, with no moving parts to fail, running silently and sipping less power, which is a real boon in a laptop. Many people end up using both, and we'll see exactly that next. Here's a practical example of video editor kitting out a busy home studio. An SSD holds the operating system and the current project, so editing and playback feel instant, while a large hard drive stores finished work and raw footage cheaply as an archive. A USB flash drive carries a rough cut along to a client meeting, and cloud storage keeps an off-site backup safe in case of theft, fire, or a drive simply dying. Each device is picked for the one thing it does best. There's no single perfect store. Let's take a quick look at USB sticks and memory cards, which are close cousins. Both use NAND flash memory, the very same technology as an SSD, just smaller and cheaper, storing data as electrical charge in cells with nothing moving. That makes them robust, silent, and ready the instant you plug them in, though they do wear out after a great many write cycles. A USB drive slots into a USB port, while SD and micro SD cards drop into cameras, phones, and Raspberry Pi boards. There are a few more devices worth knowing beyond the everyday ones. Magnetic tape stores data on a long reel, and while it's slow and strictly sequential, it's remarkably cheap and roomy, so it's still used for big archives and backups. Network Attached Storage, or NAS, is one or more drives shared over a network, so a whole team can store and back up centrally. And a hybrid drive, or SSHD, bolts a small SSD cache onto a large hard drive, trying to give you a bit of both speed and capacity. Let's trace the steps a hard drive goes through just to read one piece of data. First, it spins up, getting the platters turning at thousands of revolutions a minute. Then it seeks, moving the read-write head in or out to the correct track before waiting for the right sector to rotate underneath it. Finally, it reads, sensing the magnetic pattern and turning it back into data. And all that spinning, seeking, and waiting is why a hard drive can't match an SSD for speed. This table pairs each device with the job it's really made for. Hard drives handle bulk storage and backups where cost matters most. SSDs hold the operating system and programs where speed is everything. And USB sticks are for carrying files about. SD cards live in cameras and small computers. Optical discs distribute films and software. Cloud and NAS handle sharing and off-site backup. And magnetic tape does the heavy-duty archiving. If you learn one sensible use for each, you'll always have an answer ready. Let's see storage choices come together in a small accountancy office that has to keep client records safe. The live files sit on fast SSDs in each PC for day-to-day speed, while a NAS on the office network holds the shared files and takes a daily backup. Cloud storage then keeps an encrypted off-site copy, safe from fire or theft. That neat arrangement follows the 3-2-1 rule and matches every device to its strengths, with the safety of the data coming first. It's worth a word on file sizes because they vary enormously. A plain text file is tiny, while a 4K video is absolutely huge. And that's where compression comes in, shrinking files with formats like zip, JPEG, and MP4 so more fits in the same space. Lossless compression keeps every scrap of the original data, whereas lossy compression throws away some detail to save even more room. Understanding how big your files are helps you pick a device with enough capacity for the task. Let's get the units straight, since they come up constantly. A bit is a single 1 or 0, and 8 bits make a byte, which is roughly 1 character. 1,000 or so bytes make a kilobyte, 1,000 kilobytes make a megabyte, then a gigabyte, then a terabyte, each step about 1,000 times bigger than the last. To put that in perspective, a photo is a few megabytes, a film several gigabytes, and a modern PC drive is often 512 gigabytes or a whole terabyte. Storage can fail, get lost or be stolen, so backups genuinely matter. The golden rule is 3-2-1. Keep 3 copies of your data on 2 different types of media, with 1 copy kept off-site, often in the cloud. Schools and offices lean on network drives and cloud storage, so files stay both safe and shared. And whenever you choose storage, you're really balancing capacity, speed, cost, portability, and, above all, safety. Always ask what the device is actually for. Let's pull it all together. Backing store is non-volatile secondary storage that keeps your data permanently, unlike RAM. The main devices are the HDD, the SSD, the USB flash drive, the optical disk, the memory card, and cloud storage. And they work in different ways, magnetically, with flash memory, or with a laser. They differ in capacity, speed, cost per gigabyte, portability, and durability. So choosing storage means matching the device to the use and keeping backups by the 3-2-1 rule. So that's backing store covered, from the spinning platters of a hard drive to the flash chips of an SSD and the servers humming away in a data center. If you'd like to explore further, the reading gathered here will serve you well, with Patterson and Hennessy going deeper on how storage fits the wider system, and the National Cybersecurity Centre offering really sound, practical advice on backing up your data. BBC Bite Size and How to Geek are, as ever, friendly places to shore up the basics. Do dip into the sources listed and follow whatever catches your eye. And next we'll tackle the jargon on a specification sheet and learn to compare 2 machines fairly.